This is section 6.2, part B, multiplying matrices. The I can statements for this half of the section, I can find determinants and inverses of 2 by 2 and 3 by 3 matrices. We know that if A is a non-zero real number, then the value of 1 over A, or we can write that as A to the negative first power, is the multiplicative inverse of A, because A times A to the negative first is equal to 1. So any value, if you multiply two values together, if you end up with the multiplicative identity for that set of values is 1, or the equivalent, then we know that they are inverses of each other. To get an inverse in matrices, you're going to want to end up with the identity matrix for whatever type you have, either a 2 by 2 or 3 by 3. Remember, the inverse matrix, the identity matrix, would look like this for a 2 by 2, or if we have a 3 by 3, it would look like this. Remember, it's going to have ones across the diagonals, zeros everywhere else. So to check to see if we do have an inverse matrix, you're going to do matrix A times matrix B, and if they equal the identity matrix, then you know that they are inverses of each other. Some matrices are able to have an inverse, which means they are invertible. Some of them are not going to have an inverse, so they are singular matrix. So to determine if matrices are an inverse of each other, you do matrix A times matrix B, and then you also check matrix B times matrix A. To do this, we can just type these into our calculator. If we do matrix A times matrix B, you will end up with 1, 0, 0, 1. If we do matrix B times matrix A, again, we will end up with 1, 0, 0, 1. Since we ended up with the identity matrix both times, these are inverses. To be able to find an inverse, if we're looking at a 2 by 2 matrix, if our original matrix is A, B, and C, D, to find the inverse, we first have to check AD minus CB and make sure that it is not equal to 0. This is actually called the determinant of our matrix. We can write the determinant as the determinant of A, or you can write it in between the absolute value signs, or you can write the entire matrix inside the absolute value signs. But your determinant is AD minus CB. If that determinant value is not 0, then there will be an inverse. And to find that inverse value, you're going to do 1 over that determinant value, and then you're going to multiply it by D negative B negative CA. So you're going to take your A and your D values from here, and you're going to switch them to end up with a D on top and the A on bottom. Then you take your B and C values and just make them both negative. So if we need to find the inverse matrix, the first thing we're going to do is make sure we can find the inverse matrix. So we're going to do AD minus CB. Remember, this is A, B, C, and D. So we're going to do 8 times 2 minus negative 3 times negative 5. This is going to give me 16 minus 15, which is 1. So to find the inverse matrix, we do 1 over that AD minus CB, and then we're going to multiply it by DA, negative B, and negative C. So if we take this, our inverse matrix is going to be 1 over 1 times 2, 5, 3, and 8. Now remember, when you multiply a scalar by a matrix, you just take it and multiply it by each value inside the matrix. So our inverse matrix will just end up being 2, 5, 3, and 8, because we're just multiplying each piece by 1 over 1, or just 1. If we look at example B, we need to check our AD minus CB first. So we're going to do 2 times negative 6 minus negative 3 times 4. Or this is going to give me negative 12 plus 12, which is 0. So that means this matrix is singular, which means there is no inverse. If the instructions say to find the determinant and then find the inverse, that's exactly what we were just doing on the other one. So to find your determinant, that's still your AD minus CB. In this case, it's going to give us 8 plus 12, which is 20. To find our inverse, we do 1 over the determinant of A times your matrix D, negative B, negative C, and A. Remember, you switch your A and your D, and you flip the signs of your B and your C. So in our case, this is going to be 1 over 20. We're going to have 4, 3, negative 4, and 2. When we distribute, 4 times 1/20th is 4 over 20, or you can reduce that to be 1/5. We're going to have 3 over 20, negative 4 over 20, or 2 over 20. If we take a look at example B, we need to find the determinant first. So we're going to do AD minus CB. This is going to give me 36 minus 36, which is 0. Since this is 0, this is singular, and there is no inverse. Now to find the determinant of a 3 by 3 matrix, this is the method that you would use if you're going to do it by hand, but for our course you can go ahead and find this determinant on your calculator. So if we need to find the determinant of matrix C, the first thing you're going to do is go into your matrix on your calculator, go over to edit and select whatever matrix you want to put it into. Let's put it in A. This is a 3 by 3 matrix. So we'll put in negative 3, 2, 4, 1, negative 1, 2, negative 1, 4, and 0. You're going to quit and go back to your home screen. Then you'll hit second matrix, go over to math, select determinant, that is that first function. Go back into your matrix, select matrix A, close your parenthesis and hit enter, and it will tell you the determinant of that value. So our determinant of this matrix is 32, which means you can find the inverse. To find the inverse of it, you can just select matrix again, select the matrix you used, and then hit the X to the negative first button, which is the same one as your matrix button, and hit enter, and our inverse matrix, in this case, will look like this. So because our determinant was not 0, we knew we could find the inverse, and we found the inverse on our calculator.